Creating a new project. After registering and logging in, you are in the NV Calc program. Now you need to start by creating a new project. First, client XYZ. Project number, let's say 10, and object name, say power plant. Now something very important. You need to enter the file name under which it will be saved. Let's say that the file name could be Boiler House and temperature plus 36 degrees. Save. Now you are moving on to the phase of entering all the data into the program in order to start the calculations. We are dealing with the two temperatures, the natural air supply temperature and the outside temperature. It is important to distinguish between them because when the outside temperature is below zero, it may be necessary to heat the supply air using a water or electric heater placed in the air supply opening. Outside temperature 36, supply air temperature 36. And now the most important thing, how much heat needs to be removed. The heat emitted into the interior of the building, as specified by the engineers, is 2,200 kilowatts. For now, assume heat gains or losses to be zero, coefficient MUTRI 0.6, and expected temperature under the roof 45 degrees Celsius. Now proceed to adding individual supply and exhaust units. In this project, you will only use natural ventilation. You will learn about mechanical and hybrid ventilation in more advanced projects. Add natural ventilation units. You can add any unit which aerodynamic flow, coefficient CV is known to you. If the natural ventilation unit has the appropriate tests and certificates, this coefficient should be provided by the manufacturer. At the same time, it must be said that the program is independent of any manufacturer. You can enter any devices, but to speed up this phase, we will use the units that are listed here. Louver's Thunderbird, air supply are used here. 20 of them should be used. Wall location, the height of the center of the louvers above the floor level is 3.0 meters. CV coefficient 0.4. Louver width 2.0 meters louver. Height 1.8 meters. Wind coefficient 0. Now move on to the second row of supply air dampers needed mainly in the winter to prevent cold air from blowing directly at people who may be present there. The next group of devices are exhaust natural vents in the roof. As before, you can use the vents from the available list. Use Vulcan 2, for example. Number of vents open, 20 out of 20. Height 46 meters, which is 1 meter higher than the roof ridge. Here is some important information. They are higher than the ridge. Firstly, because they stand on frames, and secondly, what matters is the level at which the air flows out of the vent, i.e., the upper edge of the device. Coefficient 0.56. Here the dimensions are already specified because these particular units are manufactured in just one size. The process of arriving at an acceptable solution for the maximum outdoor temperature in summer is shown in video F1. The procedure for calculations in all seasons is shown in video F3.